AMODS is the Autonomous Mobile On-Orbit Diagnostic System. It's intended to give satellite operators another opportunity to interact with their spacecraft once it's on orbit. By having AMODS, you'd be able to have that additional diagnostic information so that you know exactly what went wrong, how it went wrong, and you have a picture of the failures. We started AMODS my sophomore year at the Naval Academy, and I would work spacecraft a little bit my plebe year, my freshman year. When I wrote the proposal, I'd really been looking at a whole host of previous satellite failures, and I realized that the CubeSat form factor might be the best way for us to actually solve that problem by having a small rideshare 3U CubeSat, really small, lightweight payload that could provide that extra information entirely independently of the satellite systems. The Naval Academy isn't intended necessarily to be a research organization. It's intended to develop leaders and be a leadership laboratory and give people leadership experiences. And so trying to fit building a spacecraft into the sort of regular day-to-day operations at the Naval Academy was quite a challenge. And I'd say a sizable portion, if not the majority of the spacecraft, was designed between 12 and 3 a.m., bouncing back and forth between people's rooms as we attempted to sort of squeeze all this work in. We were one of the first really cross-disciplinary CubeSat missions that the Naval Academy had done, and that we had systems engineers working, we had mechanical engineers working, we had aerospace engineers working sort of side by side to get a product done instead of just the typical capstone approach where it's all aerospace engineers. I don't know if you've ever seen an aerospace engineer try to code before, but it's not a fun experience, and if you can get a CS to come in and do that for you, you get a much better product at the end. About halfway through the development process in that we weren't allowed to use the amateur radio frequencies because it was determined that because we're a government organization we needed to have appropriate licenses to operate. NPS has been working with the cadet radio, and they had a couple extra that they were willing to provide the Naval Academy if we were able to work with it. I was fortunate enough to come out here and actually help bridge the gap between the two organizations and really get the ground station set up, get the radio set up, etc., so that we're able to talk to the spacecraft, we're able to operate the spacecraft, and as it turns out, we'll actually be operating the spacecraft from the Naval Postgraduate School, and the team out here has been invaluable in supporting that effort and making sure that we're able to get licensed, etc. Friday, April 13th, we delivered our sat to Rocket Lab for integration. It really is looking like a May-June timeframe. I think the number that I've heard is floated around is no earlier than 30 May. But really the goal is to continue the progression. So right now there's a team at the Naval Academy that's working on getting a variant of the robotic arms onto the International Space Station. They're also doing a spectacular job of refining the arm control. What we're looking to do now is take some of those more complex tasks, the autonomous routing, the routing to coordinates and stuff like that, and implement them in the International Space Station to continue to test the arm and confirm that it is able to do the missions that we're pitching for it. This is something the Naval Academy's never tried to do before. We've always just operated in the amateur bands, and so it's been a big step for us to get to the professional frequencies, and it would not have been able to do it without NPS.